Okay, so this is work that was mostly done at Willow Garage. First of all, this is not a talk about yet another method for object recognition. There are much better, smarter people, better libraries, better papers, more suited conferences for that. This is how we think we could make it more usable. Well, of course, we'll go through a problematic and then the solution we propose to actually make object recognition usable for robotics and for the ROS community. So what's the problem we face usually? Well, just look out there, right? Which methods do you have for object recognition? You got a bunch of techniques. You got papers, you got code, even BSD code. It's out there. You got frameworks, and they work pretty well. So you got libraries too. So what's the real problem there? Well, is there really a problem, right? I mean, you see those demos. This is LiveMod, for example, working almost real time on a laptop like 2 years ago, I think. You see complex objects, you see the poses and everything. Cool, that's nice. But really, what do you need to make that usable on a robot? Well, actually, it was tough for us to think on why we were not using all those techniques easily on a robot. So we had to take a step back and think about it. This is roughly how you do object recognition, and I think many people will agree with that. You might not even have training. For example, if you're trying to look for planes, it's just geometric definition. You don't need training. You get some data, you put it somewhere, you compute your model, and then you put your model somewhere, right? Same when you're trying to find your object, you get some data, you try to see if the model matches, and then you do whatever with the object that you find or you don't find. Okay, that seems pretty simple. But what's happening actually in practice? Well, the vision people, they work on that, right? That's a cool thing. They get an image, they find an object, and they tell you it's there. And then, well, the database people, they can scale with a bunch of objects, and that's nice, but they only work on that part. And then we got maybe, let's say, the ROS people, which is the communication people, that try to figure out how to make those things callable and how really to have things communicate with each other. And, well, it's not easy to get all those things working together, right? That's one thing. But there's actually a big thing missing here, which is all the in-between. So both the circles and the arrows. And this is actually what we're trying to tackle in this talk and this work. So we had some design criteria when we did that. That happens sometimes. So we wanted it to be easy for users. Because if you're going to use that, that probably means you want to use it, let's say, for arm planning, right? So you're already going to focus a lot on arm planning, on grasping. You don't want to waste your time on object recognition. So it should be fairly easy for you to use. Same for developers, right? If you develop your new thing in your own library, wherever, you don't want it to be sucked into some big framework or anything, right? You just want to have some thin layers so that it's easy for you to put on a robot and use a lot of the goodies I've talked about. You also want it to be non-intrusive, right? You don't want people to modify the code so that it works with ROS, with the robot, with everything. And for that, you need to make it as agnostic as possible of the robots, of the setup, whether you have one camera, several depth cameras, and also ROS. But no worries, there's a lot of ROS wrappers in here. Scalable, obviously, you don't want to limit yourself to a number of objects, to where databases are, what you can do with it. But contrary to other design criteria, for example, we don't mention performance. You want everything to be fast. We don't care. We're not developing the techniques. This is the work of the people developing the techniques. Everything in between, sure, that should be fast. But the techniques, that's not a problem here. So what did we do for that? Well, we reused as much as possible. I talked about databases and so on. There are great frameworks out there. So let's use them as much as we can. And same for the object recognition techniques. So what we did is define a few standards here and there to make sure that things can communicate with each other. And also a big thing that was done was this glue framework to make everything coherent. So now let's look at the solution that we propose here. And let's start with the glue. Ooh. The glue? Okay. Let's say when you're doing object recognition, let's get something slightly more complex. You get that kind of pipeline. You get some image, maybe with some depth. You do some pre-processing, maybe some filtering. You don't want to look at what's in the background. Then you launch your pipeline number 1, number 2 at the same time. You do some kind of vote, maybe some ICP, whatever, some refinements. And then you send your info. Well, great. Okay, how do we code that? What's inside the blocks? Sure, we can do it. But really, how do we glue everything together? Well, great, let's use nodelets. Well, yeah, nodelets are cool. You can pass a pointer that's going to be fast. And you can even access those things. That's pretty cool. But, I mean, let's face it. They have big problems. First, they were not conceived for that, right? They don't have a scheduler, so that's pretty bad. I'm sure if you've ever run them, like sometimes you don't realize they don't work simply because your graph doesn't finish. Like there's nothing checking for that. They're also only C++, and Ross is using a lot of Python, so it's kind of sad to limit yourself to that. If you've ever looked your Ross graph with with Arcute graph, much better. Then you can see you have a lot of bonds between your cells, right? And this is, I think, so that when one dies, it takes all of them with it down, which is just kind of messy. And then you have to configure everything through XML, which is kind of nice, but kind of a bit limiting. So what happened? Well, there's in the top right corner this thing called Ecto, which is a C++ Python framework for organizing computations. So you got Ross, which is great for asynchronous things, and then you got Ecto, which is really meant for synchronous things. So it has a scheduler, it only passes pointer, it's meant for speed. If you go to the wiki there, it's going to point you to the real documentation on GitHub. And we've been terrible at advertising it. Sorry for that. It's been ready for almost 2 years now. But yeah, it's out there. Please have fun. This was created mostly by Troy Streisheim, who had worked on that a few years before on something similar. For those who don't know Troy, he's this crazy Boost Python developer who created crazy Catkin. And if you don't use Catkin, you should use Catkin. It's good. No kidding, it's really good. So a lot of people were involved, and it's out there. So it helps you, for example, do those kinds of computations where you have your simple graph, you get inputs, outputs, you connect everything together, you get some parameters, and obviously, it scales very well to any kind of graph that can be a bit more crazy. I won't go through the coding, but at least through some of the features. The way it's built, and one more time, this was after a few years of experience from Troy with that field. All those modules are built independently in, so you don't have to, but that's how the most practical way works, into a Boost Python shell library. And this way you can actually load those libraries, do some static introspection, and figure out some properties about your cells, their inputs, their outputs, their documentation. You have a scheduler that automatically figures out how to optimize your code, how to do the multi-threading and everything. It's fairly flexible because you can code your cells in Python or C++, whatever, it doesn't matter. You just need to have some kind of small template for defining your cell. You can link everything in Python or C++, doesn't matter. Actually, you can do everything in C++, it's just slightly harder. Python has some nice features like finding things, just looking at your Python path. And everything is just running at C++ speeds. So the usual way is to create your cells in C++, link them through a graph in Python, then you execute Python, which is going to call C++, create your graph and everything. It's crazy, but it's actually very, very efficient. You can also change your parameters at runtime, so it's very nice for prototyping. As I said, with this static introspection, you can have automatic documentation. You also have a few goodies, like you can see your graph, you have automatic benchmarking, so you can know which cell is slow. There's also a GUI in JavaScript for building a graph, which is kind of fun. Cells are very flexible. Like, this whole thing is just Boost and Python. Like, whatever you do in your cell is yours. If you want to do ROS, if you want to do OpenCV, whatever, you can even put cells within cells and create those black boxes. As I said, it doesn't depend on ROS, but that doesn't mean there's no support for ROS. So all the messages of ROS, for example, have been wrapped automatically for publishing, subscribing, and for bag reading. So everything is there. It's very convenient. It's important to notice that it's one of those rare pieces of code with more tutorial samples and tests than code itself. One thing is because Troy is very anal about documentation. The other one is because he writes very optimized code. So that balanced pretty well. Everything is online one more time. Please enjoy. Now, the database. Well, we had to make a few decisions there, too. We wanted to put everything in the database. Like, why put some stuff there and some stuff on the hard drive somewhere else? Like, it's going to be messy, right? Just put everything in there. Whatever data you capture, whatever models you compute. Model could be anything, features, templates, whatever, mesh. Anything about your object, how it was captured, with which sensor. So you just put everything in there. And then we take care about retrieving the information for you for when you're doing your training or detection. Everything is just a big JSON string for your parameters and a bunch of binary blobs. That's, we didn't invent that paradigm. That's very common for the NoSQL databases like CouchDB and MongoDB. And that's just actually very, very convenient. And we make sure that all the binary blobs are as standard as possible, like an image, whatever, apply mesh, and so on. We wanted to make sure that we're agnostic to the database to use, because we used Couch at that time. It was the one we liked best for several reasons. And if there's another one, then we shouldn't limit ourselves to that. And actually, we just implemented some thin layer, and then you just have to implement a few child classes. So we did it for CouchDB, file system, the household database from Grasping is also wrapped. And that actually allows you to have different pipelines running on different databases. Some could be local, some could be remote. Doesn't matter, That's just handled transparently. So as I said, we just have this base class, just a few simple interactions you have to implement. I think it's between 5 and 10. Wait, that's the same one. Oh yeah, just a few goodies we added. That's why we chose Couch too. It has a simple HTML interface. So you can introspect your objects, check out all the models you have, all the objects you have. We even created this little nice mesh viewer so you can see from your database right away which objects you have. Okay, so the pipelines, of course, right? You want to do object recognition. So what do we offer? The first one we implemented, which is pretty old by now, is this textured object detection. Just standard bag of features with 3D check. It's actually pretty robust. We've been pretty happy with it. Nothing crazy, I'm not even sure that was a paper. But whatever, it works well. Then there's this other technique for transparent objects. Ilya developed this by himself. I'm going to develop transparent objects. As far as we know, by the way, it's the best method out there. There was just a paper at ICRA this week. And great, we had this technique. So how much did it cost to really put it in the framework? Well, 200 lines of code. That seems like much, but actually most of it is just copy and paste from some templates we have, 50 lines of which are just Python. Same thing, almost just a copy and paste. And what did he get in the end? Well, in the end, he basically had the PR to detect objects and pick them up, just without dealing much with ROS. And that was pretty cool. So we continued with other pipelines. We had this old one called Tabletop. Sachin mentioned it before. Just a very simple one, but yeah, it works well. It's basically just doing some ICP on rotational asymmetric objects. But whatever, it was easy for us to port, and then actually made the code thinner because it didn't have to deal with the action lib server, with the messages and everything. It was using what was standard in ROS, or actually the wrappers we created. Same thing with line mod, just an OpenCV. So you basically have your cells. They're just calling the library. That's it. And yeah, so that's what we have to offer right now. There are actually a few other pipelines that we have. One is obviously for model capture, because some techniques do require, for example, to have 3D model. It's a case of line mod where you need to generate a bunch of random views, right? So you need your mesh file. But mostly, if you're going to recognize an object, well, it's probably for a goal, and the main goal is usually grasping. So if you don't have a mesh, it can be pretty tough to pick up your object. So we developed this pipeline. I'll get back to it later. Just another tool, simple. As I said, for line mod, you need to generate a bunch of random views. Well, actually, same thing for transparent objects. So whatever, we have a view generator here. Cross integration. So the whole goal was really to make the framework easy for developers and users one more time, so that they don't have to care necessarily about all those things. ROS is really used, but only on the outside for communication. But we're still using it a lot. So whatever we're doing here for recognition, you can just plug in your ASYS and that will work, but you can also call or listen to whatever ROS topics or even bags and pull the data from there, recognize objects. We're also obviously publishing some messages we came up with to define what we're seeing, where, and so on. There's an action lib server. There's also an Arvis plugin where you can see what's happening. So it's taking the message, figuring out which object, getting to the database, loading the mesh, and putting it in Arvis. It's also integrated with MoveIt. They didn't talk about it, but it is. They did the job. So actually now you can just call this, get the mesh, get the message, same thing, get the mesh, and plan around your object or actually pick it up. Okay, so this is actually what we have right now. And what are we working on, or what needs to be improved with that? Well, better pipelines. The capture you saw is actually pretty coarse. It's really just figuring out the pose from the dots, the dot pattern, and then merging everything together. That's cool, but that's really not good enough. So Maria and Ila actually, that are here, developed a technique for model capture. And same thing, there were a few out there. This one just works pretty damn well, and the code is online. We just need, I think, to write a few tutorials to really use it in there, but just works and pretty accurate models. Line mods, right now, we return you the pose during which the model was captured, so it's not necessarily very precise. So we need to do an ICP step in there. And also, we just have a color modality that manually just added, so we need to play with that a bit more. Transparent objects. Actually, right now, to train your object, you need to have a painted version of your object. You do some kinfo on it, you get a mesh, and then you play with that. Or you can have a CAD model. But actually, Ilya is working on a technique to learn your object without painting it. It's pretty crazy, but yeah, that works. We're also putting more pipelines. For those that are familiar with object recognition, the parts-based object recognition by Divan Ramanan is the one that won 2 Pascal VOC challenges, I think 2009, 2010, or 2010, 2011. So it's a pretty good technique. It actually recognizes articulated objects, like bikes or bodies or whatever, dogs and so on. So we had an intern implementing it, works pretty well. We haven't put in it yet because the training is actually a bit problematic. You need to select by hand a bunch of parts. But if you just load the models that Diva put online, like I think you put 10 to 20, then it works. So yeah, the code is online. If anybody's interested in collaborating and speeding that up, please. More integration. So object manipulation is the last part of the pipeline with Move It and planning and everything that's still a bit missing. It's still using the old tabletop. The new one is more optimized, much faster, complies to all the standard. So really, that's being switched. Same thing for the DB interface. So there is a household DB interface. Would be nice maybe to agree on a few standards there. But I think, yeah, manipulation is working with Movie to clean all that. So should be out there fairly soon. A rep would be very nice. So the messages were created a year ago. They got changed during last year. I think they're getting pretty stable now. So it would be nice really to ask everybody what they think of them, if they're flexible enough, and so on. And then some people were interested in having the DB be its own part. Has nothing to do with object recognition, indeed. Could be its own package, so sure, why not? The conclusion already. Good. We were late, so now we're going to be on time. Everything is out there already in packages. It's all BSD, C++, and Python. Ecto, you can even compile it without ROS. I mean, as I said, it doesn't depend on it. You just need Catkin. We got bindings for a bunch of libraries out there, OpenCV and so on. For the core of object recognition, you really have the core that has nothing to do with ROS, and then the messages, and the ROS with all the plugins and actual NIP servers. And the 4 pipelines I mentioned, and a few extra pipelines there. So yeah, that's basically it. So I hope I convinced you that this is not about sucking everybody else's work into some library or anything. It's just about integration, how we can make everything collaborate better. So please, if you feel like it, your work, it's going to be yours. You just have to add a few lines of code, or we could create a package for it that would just make your object recognition or your database or anything out there just interface easily. So just go to the wiki. It has the pointers to the real documentation in GitHub, and that will be it. I will now take questions.
Thanks for your talk. Are there some questions? A lot of new robotics perception pipelines these days are very interactive. So there was a workshop at ICRA. Mm-hmm. So is it possible to implement something like Oliver's Brock pushing objects around to determine their kinematics, or separating objects on a table if there's clutter?
Mm-hmm. So one of the paradigms we had in here was based on the snapshot, how much can you recover, right? So you take a picture, 2D, 3D, and what can you find? So that's really the whole paradigm, and then you execute your graph. Now what you can do is actually in each cell is a piece of code. You can have some static variable, you can have your own local database, and you can keep track of things, right? And therefore, if you see an object and you move your camera you can adapt those things. We thought it would be better actually to do a whole tracking or maybe some environment map, a semantic mapping, and then keep things in there. But nothing would, the way I would do it, I mean, I described one way which would work in this framework, but the way I would do it is really have a server that has this environment map, call that thing, gets a result back with a pose, moves the camera, gets a new TF, therefore gives a new TF to the pipeline, gets a new result, and then updates separately. Otherwise, you're going to start complexifying that thing, which you can, but I don't know. I think it's better to deal with Octomap and everything, for example, separately.
More questions? Okay.
Most of your talk focused on object recognition, but it seemed like some of the improvements we made in terms of building generic computation graphs and dealing with the problems of nodelets have broader implications. Can you speak to other domains this might be applied to, or whether there's conversation between this project and Roscon moving forward?
So one more time, this framework, Ecto, was created by Troy. He had experience with it, with a physics community. His stuff previously ended up on the South Pole. And Troy was never impressed by it. It's like, yeah, just wrote 6,000 lines of code and does its thing. That's cool, you know, like, this is definitely not new. There are people building better schedules out there. We talked to some people at Berkeley for that. And, you know, the cool thing about it here is that it's Python and C++. It is doing both at the same time. There are definitely better things out there if you want, for example, to dump data onto a GPU at the same time and CPU. So really, like, the goal here is just to have something usable, not necessarily crazy optimized. On the CPU, yeah, it's pretty good. Now, indeed, Troy was definitely working on the core of ROS, and we're talking about, with the core team, about how to integrate that in there. Ecto was, for example, the testbed for Catkin too, just so you know, so the core was definitely involved. But indeed, we've talked already to see how we could make things faster for the core, right? We've talked several times about replacing messages by pointers if you're local, because it's going to be faster. It can make sense sometimes, like if you're doing things synchronously, definitely. Asynchronously, it's a bit tougher, but so how much can be leveraged to Ecto or not? It's definitely there, and those guys, or I mean, everybody, well, mostly those guys, know about Ecto now. So yeah, please, if you think anything in there could be reused for the core, like the fact that it's Python, C++ agnostic, that can be actually pretty powerful in there.